Alrighty, friends, I decided to make this video because this should be review, and that will cut down on our teaching time in class Thursday so that you'll have more time to work on your homework and chat with your friends. So we're going to get through the basics of how to solve a quadratic using the quadratic formula. We've already learned kind of when and how to do factoring, when it's in standard form, and factorable, obviously. Then we did, sorry, I can think and talk faster than I can write. Then we did solving using square roots. That's going to be if it's in vertex form. That's going to be if your standard form has a b value equal to 0, so there's no plane x. Then you can use square roots to solve. And then what we're going to do today is we're going to use the quadratic formula. So if you don't recall the quadratic formula, this is not new to anybody in class, or it shouldn't be. Again, this is going to be when it's in standard form. Your b is not equal to 0, so you can't use square roots, and it's not factorable. You can use it on a factorable problem, but I'll show you why that's a little bit more cumbersome. Okay, so this is going to be where, keep in mind, we're looking for our x values where our parabola crosses. So if it crosses here and here, those are x values. It's crossing the x axis. So when I go to solve it, it's going to be x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm sure some of you know a song. I don't really do songs. I'm sure if you ask Miss Meyer nicely, she'll sing you the song. Okay, so that is going to be something that you need to know. This plus or minus that you have going on right here, that's where my two possible options are going to come in. So let's do an example. Now, if you're wondering where the letters come from, it's simply coming from the fact that it's in standard form. So you have an a x squared plus or minus a bx plus or minus a constant c. So the a, b's, and c's that you see in the equation are simply these a coordinate, coefficients, b coefficient, and then the constant that you pull out of the equation. So let's say we had something pretty straightforward. Let's say we had an x squared minus 5x minus 14 equals 0. First thing you want to do is identify a. Well, that's going to be the number in front of x, so that's just going to be a 1. Then we want to find our b, and since b is the number in front of the plane x, then that's going to be a negative 5. And then in order to find c, we're going to use that constant, which is going to be a negative 14. So when I go to use my equation, my quadratic formula, I'm going to have x equals, now I need to use the opposite of b. So I'm technically using the opposite of a negative 5, which is going to turn into a positive 5, plus or minus the square root. Totally regret writing my c there because now I have no space for it. All right, plus or minus the square root of, and this is where it becomes a little tricky. When your b is a negative, you have to make sure that when you square it, you're not going to get a negative. Because keep in mind, when you type this into your calculator, it's going to calculate that, and that is sad face. That is not what you're going for. You want to square the whole thing so your calculator knows that it's a 25, not a negative. So you have to be really conscious of that and either use the parentheses like I did or just not even put the negative, knowing that when you square something, it always comes out positive. This right here, my friends, is the spot where people most frequently get these wrong because they type it into their calculator wrong and then just write down whatever the calculator said. Okay, so minus 4 times my a times my c, including the negative sign, all over 2 times my a value. So this is clearly a calculator-driven thing. This part out in front becomes a positive 5 plus or minus. And then what I do is I just do this whole thing on my calculator. So I'm going to take my 5 squared. I'm going to make sure, I just don't do the negative because I know it's never going to be negative. But if you do, make sure you use those parentheses. And I'm getting 81 under the radical. And then on the bottom, a 2. Okay, so here's where I'm going to be getting my two possible answers because the square root of 81 can either be a positive or negative 9. So then I'm going to be finding my two solutions by saying 5 plus 9 over 2 or 5 minus 9 over 2. This will become 14 over 2, so my first solution is a 7. This will become negative 4 over 2, so my second solution is a negative 2. So if I were to draw this original parabola, I already know now that it's going to cross at 1, 2, 3, 4, 5, 6, 7, and at negative 2. Then I could still find my vertex. My axis of symmetry is going to go right down the middle. It's a positive square. It's going to open up, all that good stuff. But right now I'm focusing on that. Now, that was a lot of work because this one actually could have been factored. So that's why you don't really want to just use the quadratic formula every time, because in this case, I could have thought, what makes 14 in a way that subtracts to be 5? Pretty quickly could have done 7 times 2. In order to get my negative 5, I would have needed a negative 7 and a positive 2. So then my solutions or zeros would have, not surprisingly, come out to be negative 2 and 7. So I'm not advocating for you to use the quadratic formula when factoring is an option, because ultimately factoring should be significantly easier since this is my factoring work and all of this is my quadratic formula work. So if you look at a quadratic and you have the option to factor it, then that's what you should do. But if you don't have the option to factor it, then you're going to need to use quadratic formula, and it's going to come out to be some like really crazy messy numbers. So let's do one more example, of crazy messy numbers. And then that way you'll be able to already know that part of the lesson. Let's see. So say that instead I had something like 2x squared minus 7x minus 13 equals negative 10 to solve. Well, first of all, I need this equal to 0. So if I need a 0 here, I'm going to have to add a 10. So when I do that, I'm at 2x squared minus 7x minus 3. So if I was going to solve or try to see if this factors, since there is a number in the front, I'd have to incorporate both. They make a 6, and the only way I could split 6 up is 1 times 6 or 2 times 3, but I would need them to subtract, not add, but subtract because of this sign to be a 7. Neither of these subtracts to be a 7, so this is not factorable. And if it's not factorable, then my only backup plan is going to be the quadratic formula. Because it just means that it's going to cross at messy points. It's not going to cross at 7 and negative 2. It's going to cross at some weird irrational spot. So I go ahead and I set up my A equals 2, B equals negative 7, C equals negative 3. And again, that's not like some rocket science. I'm literally just looking at my coefficients and my constant. So my x's will equal the opposite of b, but since that's negative, it'll be a positive, plus or minus the square root of, I'm squaring a negative, so I need to make sure that's going to come out positive, minus 4 times a times c all over 2 times a. So again, I always like to do this part under here, which is called the discriminant, foreshadowing for tomorrow's lesson. I always like to do that first. So I'm going to have 7 plus or minus the square root of something over 4. So I'm going to get my handy calculator out. 7 squared minus 4 times 2 times negative 3, and I got 73. So unlike my really user-friendly 81 up above, 73 is not a perfect square. So I'm going to get my two solutions by doing 7 plus the square root of 73 over 4 and 7 minus the square root of 73 all over 4. Be careful when you do this on your calculator that you find this entire answer and then divide by 4. So practice on your calculator and make sure that we get the same thing, because people don't get this wrong because they don't understand the quadratic formula. They just don't type it into their calculator properly. So I am getting, and I'm going to round to the hundredths place, I suppose. For this one, I got I'm sitting in a dark room and I can't see, 3.89-ish because I had to round up. And then for this bottom one, if I do 7 minus square root of 73, that answer divided by 4, now I'm getting negative 0.39. And so then what that tells me is if I were drawing this one at 1, 2, 3, and not quite 4, and at negative 0.39, I'd be crossing the x-axis. Looking back up here, it's going to be a positive. It's going to open up. My axis of symmetry is somewhere in the middle, blah, blah, blah. I'm not focusing on that, but those would be my two solutions. And so that's going to be your quadratic formula. We're going to be doing some practicing on that tomorrow. If you peek ahead, there is an IXL that's strictly on solving. And then the other one is on number and types of solutions where we need to talk about the discriminant in more detail. And we're going to do that in class. But by watching this video, that'll cut down significantly on the time I have to teach in class tomorrow. So thanks for watching. See you tomorrow. Bye, guys. If you want to jumpstart on that IXL, go for it. Otherwise, it'll be waiting for you tomorrow.